In the name of Allah, the most gracious, the most merciful, praise be to Allah and peace and blessings be upon the messenger of Allah, our master Muhammad, and upon his family and companions altogether. Now let's continue with a new lecture on current and voltage transformers. The winding resistance test measures the resistance of the VT's windings, which include the primary and secondary windings. The primary windings resistance is tested with a multimeter, while the secondaries is measured by injecting DC current into it. This generates a voltage across the windings terminals, which is measured with a voltmeter. Using Ohm's law, the resistance is calculated by dividing the voltage by the current. This process helps evaluate potential damage to the winding. It's known that when DC current is injected into the winding, a voltage is generated across the terminals of that winding. We measure this voltage by placing a voltmeter across its terminals. Then, using Ohm's law, we simply divide the DC voltage by the DC current to get the resistance of the secondary winding. This helps us evaluate any possible winding damage, such as short circuits between turns or open circuits, and ensures everything is functioning properly. To evaluate possible winding damage, such as short circuits between turns or open circuits, and to ensure everything is functioning properly, like short drops between turns or windings, open drops, and sharing the connection. The sharing being converted. When the sharing is converted and the sharing is shared, the sharing is converted. Ensure accuracy by comparing the winding resistance values with factory test values. After the post is transformed, post is converted to post design in a detailed manner. We take the values of the primary and secondary winding resistance and compare them with the factory test values to ensure their accuracy can be estimated by comparing the measurement results with results from measurements performed in the factory or during commissioning, or with results from measurements of other phases. Since the resistance value is sensitive to temperature, we will find a difference between the factory and site values. To solve this problem, scientists use a reference temperature not found on Earth, 75 degrees Celsius. When measuring primary and secondary, we convert these values from ambient temperature to 75 degrees C and compare them with factory values, also converted to 75 degrees C, to verify accuracy. The third voltage transformer test is the ratio test after the IR and winding resistance tests. The winding resistance test checks the winding for issues. The third VT test is the ratio test. After the IR and winding resistance tests, we apply and measure AC voltage. Dividing gives the transformation ratio to verify. Ensure the actual VT ratio matches the PC100 VT ratio, generating up to 2000 volts AC for verification. The PC100 can generate up to 2000 volts AC for injecting into the VT's primary side to verify its ratio. During the ratio comparison, the CPC also checks the VT by comparing angle on both sides. On the primary side, we compare the high angle, and on the secondary side, we compare the reference angle, and it inputs the input for marketing. The fourth test is the polarity test. Connect a voltmeter to the secondary, positive to X1, negative to X2. Connect a DC battery to the primary, positive to H1, negative to H2 via a switch. Press the switch. If the needle or DC reading is positive, polarity is correct. Confirm values from IR, winding resistance, ratio, and polarity test, and ensure VT wires to panels are correct. Perform VT secondary injection test. So when we press this switch, if the needle on the secondary moves in the positive direction in the case of an analog meter, or if the DC voltage reading is positive, that means the polarity is correct. After confirming the values from the IR test, winding resistance test, ratio test, and polarity test, we need to ensure that all the wires coming from the VT to all the panels are connected correctly. Then we perform the VT secondary injection test. The VT secondary injection test is conducted by applying a three-phase voltage to the secondary side of the VT and checking these values all the way to the last point. It's preferable that these three values are different to ensure that the red is connected to the red, the yellow to the yellow, and the blue to the blue with no mixing between them. Now we have confirmed that the VT is functioning properly and that the secondary side is good all the way to the last point. We just need to make sure that primary side of the VT is also in good condition